check. Okay. All right, let's go ahead and get started. Thank you, everyone. This is normally a talk that I give in an hour-long slot, and we've got an abbreviated 40-minute slot, so please bear with me. I will try to still make sense. My name is Larry Garfield. You may know me online as Krell. If you want to make fun of me on Twitter during the session, that's where you do so. I highly encourage it. I'm the Director of Runtimes and Integrations at Platform SH. We're a container-based platform as a service hosting/development solution and the technology underneath Sensio Cloud. So if you end up using Sensio Cloud, that's us plus some stuff. I was one of the lead developers on Drupal 8. I'm the Drupal representative to the PHP Framework Interoperability Group. If you were in here yesterday for Michael Cullum's talk, you know all about that now. And I'm an American, therefore huggable. I'd like to start off today by talking about the stomach, your stomach specifically. The stomach is a very important and key part of the digestion process. It breaks down the food you eat and into raw materials and calories that then powers the rest of your body. The purpose of digestion is to provide you with calories, but doing so also burns calories. It takes work to break down and digest food. Now, years and years ago, millions of years ago, when humans lived in caves, like this one, our diet, someone gets it, okay. Our diet consisted primarily of plants. Meat was hard to come by because it tended to run away from us while we were trying to eat it. Problem is, plants are actually a lot harder to digest. The material, the cellulose, is tougher, and so it takes more work to digest plants than it does to digest meat. So this meant we spent a lot of calories digesting food to get calories out of them. Is the way to turn down the mic a little? I'm getting a lot of echo. He's ignoring me. This started to change with the development, with the domestication of fire. Evidence is a little sketchy on how this happened, but it was somewhere between 400,000 and 1 million years ago, humans started to domesticate fire. And one of the most important things we did with fire, somewhere around 250,000 years ago, was learn how to cook. We started preheating our food by sticking it into a fire before eating it. That fire broke down the material in the food and made it easier to digest. It made some foods that would otherwise be toxic edible by simply breaking down the toxic portions of it into non-toxic components. This meant that we could spend fewer calories in our stomach digesting food because we'd already pre-digested it with a fire. We outsourced digestion to a fire. What does that mean? It meant that we could spend fewer calories digesting and put more calories towards thinking. Humans as a species evolved to have weaker stomachs and stronger brains because we needed fewer calories in order to eat. We got smarter as a species. We genetically got smarter by outsourcing to technology, outsourcing to fire, things that we normally would need to do ourselves. Humans got smarter by making our tools do our work for us. We're all developers here. Computers are tools to do boring rote work. That's what they're for. So let's use them to do boring rote work so we don't have to. The whole point of human technological development, the entire history of humanity, is making our tools do our job for us, making tools do work for us so that we can move on and do something else instead. And your job as a developer is to write code, right? No, it's to write correct code. It's to write code that doesn't have errors in it. If you write lots and lots of code that has lots and lots of errors, you are worthless as a developer. Our job is to write correct code. So how can we be smarter about doing that? How can we make tools that find our errors for us so we can focus on business problems? We can focus on the parts of debugging that actually require insight and intellect. We can focus on figuring out what the client actually wants because they're not going to tell us. One of the best tools for finding errors for us is something called static analysis. Static analysis is essentially the process of looking at code statically and saying, I can tell it's wrong just by looking at it. Without actually executing the code, I can look at it and tell you there's a bug. And if you can do that, then so can your tools. In this case, a tool could be the PHP engine, it could be your IDE, it could be some separate analyzer tool, it could be your documentation tool. Tool is a very generic term here. The point is, you can make your tool tell us in advance if something is wrong without having to try running the code to see what might be wrong. We can pre-digest our code without executing it. We can pre-execute our code without having to run through every possible code path manually. The simplest form of this, which I hope I'm preaching to the choir on, please be using EAL for development. If you are not developing under EAL, it means you are cheating yourself out of an excellent debugging tool that can tell you when an error probably will occur, or may be occurring here. And most major languages have some option to set them into extra pedantic mode. This is what PHP's is. Use it. In any language, use the extra pedantic mode. Another good tool, PHP Mess Detector. Who's heard of Mess Detector before? Excellent. Who's using Mess Detector? Not quite as many hands, but still most of the room. Good. This is a static analyzer that goes through your code and says, these things are sloppy. Your cyclomatic complexity is too high. Your classes are too long. Your files are doing weird things. That may or may not be bugs yet, but probably they're the places where bugs hide. This is static analysis. And it can get even better if we can code in a way that makes static analysis easier. Can we approximate our code in code? Can we code in such a way to give static analyzers more to work with, to make bugs even more obvious? Can we include a junior version of our code in our code that makes it easier for a static analyzer to statically analyze? That's what they do. Let's look at an example. We have this function here. It takes two parameters, a and b, and it's going to multiply a by itself and b by itself and add the result. Okay, nice. What are all the possible return values of this function? There's an infinite number. What are all the possible inputs? There's an infinite number. Okay, it caps out at PHP max int, but that's close enough to infinite for my purposes. I still can't write unit tests for all of it. But can we approximate this? Well, any number, let's say integers for the moment, is going to be positive, negative, 0, or Now we only have 4 possible values for inputs and outputs. Can we go through that and say, okay, what are the possible outputs now? Well, we know what the rules are for mixing positive and negative numbers when doing math. And this is almost all of them. A positive times a positive is a positive. Positive times a negative is always going to give a negative. We don't know anything else about the number, just its class, positive, negative, and so forth. So we have a number multiplied by itself that's always going to be positive times positive, or negative times negative. Both of those give a positive. So the result there is going to be positive. The result there is going to be positive. So we know we're going to add 2 positive numbers and get a positive. Technically, if these are a and b are both 0, 0 times 0 is 0, plus 0 times 0 is 0, to return 0. So we know there's exactly one case in which our output will be 0, and in all other cases, the output would be positive. We've just proven, by looking at it, that we can never have a negative return value from this code. We just did that in our heads. If we can do it in our heads, a computer can do it in its head even faster. Let's look at some error conditions. Here's 2 functions. We've got one called bigger that's going to take 2 values and return either the first value or 0. And then another one that's going to take 3 values and do some math on it. And we're going to call bigger and pass its results as the 3rd parameter to compute. What do we know just by looking at this code? we know that if B or C are 0, we end up with 0 times something, which gives us 0, divide by 0, and this will fail. Except in PHP, that's later, so that'll fail. When we combine these two functions. Let's try a different version. So let's say bigger now is going to return either the string the first or the second. And we know that if B or C are 0, it'll fail. If A, B, or C are not 0, or are not numbers, then this code doesn't make sense and is going to fail. Which means what we know is that this code will always fail. Except in PHP, where casting a string to an int will work and give us a 0. And so it'll still fail, even in PHP's screwy variable handling. Now let's try putting that abstracted version of just dealing with number or string into the code itself. We can just annotate the code and say, okay, bigger is going to take 2 numbers and returns either a number or a string. And compute is going to take 3 numbers and return a number. So I don't know if this is going to work or not, because I could be returning a number here and that matches up with number, or I could be returning a string and then it breaks. Maybe is the worst possible state for any bug to be in. If, in this case, I can annotate that it's going to return a string, and I'm pretty much guaranteed, in fact, not even pretty much, I am absolutely guaranteed this code can never be correct. This code will never be correct. I can guarantee that. If, on the other hand, I know that it returns a number from bigger and pass that to compute, then it cannot possibly fail. My algorithm may be wrong, but at least my functions fit together properly. Good tooling can tell you this if we give them enough information to analyze. And again, the tool could be the PHP engine, your compiler, your IDE. In part because the computer science world and the software engineering world have been using the phrase type systems to mean 2 completely different things for the past 70 years. But, what do you expect from academics? Also, there are lots of different kinds of type systems that different languages use. The most generic statements and description of a type system I could find is this one. A type system is a tractable syntactic method for proving the absence of certain program behaviors by classifying phrases according to the kinds of values they compute. Put another way, semantic metadata about the code that we can use to find bugs. That's a type system. I could do an entire college course on this subject. I'm not going to, so we just get one slide. Type systems can generally be classified into static and dynamic. A static type system is specified ahead of time in the code and analyzed by the compiler. It does not impact runtime, it's handled by the compiler step. Dynamic typing is information that is derived from the compiler and used at runtime. Important thing to note, these are not incompatible. Many languages, in fact, do both, including PHP. You can also have explicit or implicit types. Explicit types are those that you specify in the source code, it's annotations you provide to say what shape of variable something is, whereas an implicit type is something that the compiler or the runtime can derive from context. This function returns an integer, therefore I know that this variable it assigns to is going to be an integer. That's implicit types. You can also have strict types or weak types. Strict types, a variable can change its type, change its shape, only explicitly, only when it's explicitly told to do so. With weak types, the type can change implicitly in cases where it makes sense, for some definition of makes sense that's going to vary by language. Note, the word strong does not appear anywhere on this slide. Strong typing means type system I like. It's not actually a useful category. So what does this look like in PHP? Well, let's work through an example of where types are really useful. So we've got a couple of functions here. We've got a compute shipping function. We're just going to take an address, US address in this case, because that's what I'm most familiar with, and a user object. And we're going to pull the user's address off the user object, figure out the distance from the user to that location, say it's a factory that we're shipping something from, or the warehouse, and then multiply that by 0.5 because it's going to be 50 cents per kilometer. Okay, and what's wrong with this picture? What's the bug on the slide? Shouldn't address have two S's? You'd think so, but typos can be part of the standard. Refer is supposed to have two R's. The IETF doesn't know this. You can also have different dialects. The word canceled. How many L's are in the word canceled? Who says 1? Who says 2? Guess what? Both are legal depending on which English-speaking country you're in. I've actually worked on code bases that had a little of each. So spelling is not a viable way to guarantee that something is a bug. Let's assume for the moment that yes, this is a bug, and it should be address with two S's. Okay. Now, is that address field even defined? I don't know. Is user an array? In which case, we could even do this operation in the first place. I don't know. I couldn't tell you if there's a bug here or not. Oh, user's not. It's just an ID. It's an integer. So this code is going to break horribly. This is a place where type inference, implicit types would come in handy, but PHP doesn't do that, so we can't. So some languages have that capability, PHP does not. Okay, we can do this much at least. Explicitly say that the user must be an array. And now PHP will catch this error for us and say, hey, an integer is not an array, you think. But I still don't know if address is defined. I know it's going to be an array, but is address even a defined property in the array? No, it's not. Oh, well, that's helpful. I still can't verify that this information is correct. Just telling me it's an array doesn't tell me anything useful. If you take nothing else away from this session, it's that PHP associative arrays are not a useful data structure. They are a terrible, terrible, terrible way to model data for this exact reason. They tell you nothing. I'm a Drupal developer. I speak from experience. Got a lot of Drupal developers in the room. Okay, then. So what can we do instead if we want to actually property that this is? We use a class. Because PHP doesn't have structs, we just have classes. Okay, cool. So now we know that that address has two S's, good. User is going to have an ID and an address, and we're just going to assign those on the constructor. All right. We're going to specify a type of user for compute shipping. We're going to create a user and pass that in. So now we know that that property is going to exist. That address property will exist. Is it null? Is it a string? Is it something else? I don't know. Oh dear. Oh, that it's an array. Is this going to work? Comparing a string to an array? I don't know. It depends on what distance between wants to do. Is it going to take a string and array and still work? I have no idea. So let's define address as an actual structure too. We'll make that a class with 4 properties, a street, city, a state, and zip. Zip is the American postal code system. And now we'll create an address and assign, with its properties, and assign that to a user, and then we can make source also that address object, and now pass both of those to compute shipping, and insist on getting an address in both cases. Excuse me. Pass the source and the user to compute shipping, and then we'll pull off the user's address and call distance between. And this, statically, we can look at it and say, this really shouldn't error. This shouldn't be possible for me to get an error here that isn't a syntax error, unless someone changes the value of user address, because we can't enforce it having a given type. PHP doesn't have property level types yet. So this is still not safe. How can we fix that? Well, the only way to fix that in PHP is to wrap it on a method. So we now make address private or protected. We're going to insist on an address object in the constructor to assign to it, and we're going to access it only through this getAddress method, and we're going to say that return types. Yay. This is a new feature in PHP 7. As of PHP 7.0, they are not nullable. If you say a function is going to return a value of a given type, it must return the actual value of that type, not null. In 7.1, which was released about 15 minutes ago, good data for this talk, you can flag it as allowing null as a return value by putting a question mark before the type. I would recommend you not do that the vast majority of the time, because the explicit types and non-nulls are good for you. Why? Who's written code like this before? If you're working with Doctrine, you've probably done this several times in your career. Yep. And so you write this code, it's nice and simple and easy, and you run it, and oh dear. Now what do? We sigh and wrap everything in a dozen if null checks or if true checks or whatever, and our nice simple one line of code is now 12. And that's no good at all. Instead, if we explicitly say that the type returned from each of these methods must be of a given type and cannot be null, we know it's safe to do this with. This is going to be safe, because if the code is even capable of returning null, that code has a bug, and we need to go fix that bug anyway. It's not an acceptable condition. It breaks our contract. So what do you do for error cases then if you can't return null? Well, there's two options. Depending on your use case, one or the other may work better. One is to throw an exception. The other is to define an empty value that makes sense in your context. Which one should you use? That's up to you and your specific use case. My general guideline is for something like a repository or a service of some kind, throw an exception. In this case, we're trying to look up a user. We're insisting on getting a user object back. If we can't get a user object back, the odds of the rest of the code coming after this working are pretty much nil, or null, whatever. So let's just throw an exception, bail out. This is, someone asked for a user that doesn't exist. That's not okay. Something has gone wrong. Let's handle that way. For a value object like address, it can be easy to define an empty version. For a string, the empty version is an empty string. For an int, the empty version is 0, sort of. For a value object, it's, well, what do we define? So let's make an address interface and give it 4 methods, and our empty address version just returns an empty string for all of them. So we still have an object of the right shape, it's just empty. Does that make sense? That depends on your business logic. And then we have our real address object that has real implementations of things. Which one do you want to use? Again, you have to make that call based on your situation. Incidentally, while we're talking about it, do not ever return false unless your other return value is true. Returning false for an error case completely undermines all type expectations. It's telling your user, something went wrong. I'm not going to tell you what. You get to guess, and you have to throw a bunch of if-false statements all around your code to deal with me. Don't be that much of a jerk. Please. Don't be that jerk. All right, so let's go back to our code here. We've got our user object with an ID and an address, and it's going to return an address interface, so we are guaranteed that our types are correct. Compute shipping wants an address and a user. So we're pretty confident all of this is going to work. We have a checkable definition of the user. We have a checkable definition of address. Our tools, IDE, compiler, whatever, can verify these for us if it gets past us. And we also, just looking at this now, because we can see the types, see the shapes of the data we're passing around, we can look at this and say, you know what? There's that whole suggestion of Demeter thing. So all we're using off the user is the address. We're not using anything else. So, okay, let's just pass in the address instead. We can pull the address off the user and pass that in and eliminate a layer of unnecessary dependency. Could we have made that change before? Yes. Would it have been as obvious that we could make that change? Arguably not. Okay, now what? Well, we still have distance between. What's it returning? Is it going to return a whole number of kilometers, a fractional number of kilometers? Do we care? I don't know, maybe? Let's insist that it's going to return a whole number of kilometers. And then compute shipping, because we're doing fractional math on it, is guaranteed to return a float and Scalar types. PHP 7 finally has scalar typing, which roughly translates as, if you run into Andrea Fault or Anthony Farrar at a conference, buy them a drink. They're the ones who finally made this happen. It only took 11 years. This is, as far as I'm concerned, the most important feature in PHP 7. Okay, second after the performance boost. But after performance, the most important feature change in PHP 7. You can now type any parameter or any return of a function or method as an int, float, string, bool, array, any class, yours or someone else's, callable. As of 7.1, you can now type it as iterable, which means array or traversable, which is freaking awesome. Or return types, you can specify void, only for the return type to say this function will not return a value. That's mostly useful for interfaces to say, no, this method doesn't return something. If your implementation tries to do that, you're breaking the contract. Important to note, it's int and bool, not integer and boolean. There was some discussion about which ones to use. The core team settled on int and bool, so we roll with that. Integer and boolean are not valid names. Where is this useful? Well, let's look at this address interface again. What exactly does getStreet return? Is it going to be a string, like we saw before? Or is it going to be a street object with a street name, and apartment number properties? Both are completely valid ways of doing it. Both are correct in certain use cases. But which one are we doing here? I can't tell. Oh, okay, I'm returning strings. I now know that getStreet is going to be a string, not an object with properties on it. And then I can also type in my constructor to say, I want a street, city, state, and zip that are all strings. And then I'm going to have my methods return just those data types as well. I can type those as well, because I have them here. And so now, come on, I can create an address and pass it to a user and call compute shipping, and everything's fine, right? No, it's not. Why is it not fine? Because postal codes in the US can sometimes begin with a 0 in certain parts of the country. And what happens when you have an integer that begins with 0 in PHP? It's octal. So this is not, in fact, the zip code 02113. It is the number 1099. And so because PHP will dutifully cast from an int to a string, because PHP is weakly typed, we will now save 1099 as a postal code in our database, leave it there for 3 months, pull it out later when the user tries to order something. Our shipping system will completely barf on us and have no idea what to do, and we'll have no idea where this bug came from. This is sad. So what do we do about this? Because PHP is a weakly typed language, PHP will cast back and forth between variables and primitive types all the time for us. What do? This was the biggest dispute in PHP scalar typing, how to handle this. This is why it took 11 years to get in, because no one could come up with a good answer here. The answer to should we let it convert or not was both. PHP has both a strict mode and a weak mode for types. It is in weak mode by default, so if you do nothing else, then your code is going to be running in weak mode. In weak mode, everything casts the way that you're used to PHP casting. You pass an int to something that wants a string, it'll deal with it. You pass an int to something that wants a float, it'll deal with it. You pass a bool to something that wants an int, you'll get either a 1 or a 0 out of it. With one exception, if you pass a string that is non-numeric to something that wants an integer, you'll get a notice, but otherwise it'll still work, because that one is pretty much always guaranteed to be wrong. This makes sense because everything on the web is a string, ultimately, and it makes no sense at all because we're completely undermining our type safety and have no ability to guarantee, oh, this is in fact the data I want, this is the shape I want. What you can do instead is force your code into strict mode by adding at the top of your file this declare statement, strict types equals 1. This comes right at the beginning of your file before even your namespace declaration and affects only that file. So in this case, we're going to say when we return zip, if zip here is not actually a string, if it's an integer masquerading as one, type error gets thrown. In weak mode, it would just turn it into a string and be done with it. In strict mode, it will complain at us, as it should. This also means your IDE can detect, hey, you're in strict mode, you're returning an int when it wants a string, this is clearly wrong, please fix it. Note, this affects calls and returns from this file only, from this file. This affects this return statement. It does not affect the constructor. Inside the constructor, I will get 5 strings. But if someone passes an integer to them, or passes an object that has a toString method, this will work fine. It won't error out. If we set this other file into strict mode, however, this affects calls from this file. And now, because this function, or the constructor here, wants a string, and we give it an int, it will give us a type error. It's a little bit subtle here. It's kind of tricky to understand, but once you do, it makes a ton of sense, because this way, strict enforcement is always opt-in, and someone else deciding they want their code to be in strict mode doesn't force you to go into strict mode when calling them, when interacting with them. You're saying, in PHP, in my code, please be pedantic. In strict mode, the only automatic cast is that an int is safe to pass to a float, because that is in fact mathematically safe to do in the vast majority of cases, and most strict languages allow that too. That only creates a problem if you're dealing with obscenely large integers. If you need to pass something otherwise that is not of the correct primitive type, then you can either cast it explicitly or redesign your code. And really, you should just redesign your code, because if you are not lining up your types properly, it means you don't actually understand your problem space. You don't know what data you're dealing with, which means you're probably doing it wrong. So when should you use strict types? Remember what we said earlier about setting your system in your programming language into extra pedantic mode? You should use strict types almost always. If you're writing PHP 7, your default should be to force your code into strict mode. This will catch the most bugs and give you the best type safety and the best safety net for your code. It gives your static analyzer the most to work with. The one exception to that is when dealing with input, because your input is pretty much always going to be a string, and so passing something from there to something that wants an int, okay, fine, let that cast automatically in that one case. This gives you the maximum type safety with the minimum amount of annoyance. And it also forces you to then put your input in a separate physical file from the rest of your business logic, which you should be doing anyway for just good design purposes. This is also good for documentation. Who's heard the line, good code is self-documenting? Yeah? Probably everyone's heard that at some point. Anyone who says that and is not using scalar typing in strict mode is a hypocrite. Documentation, doc blocks, can go out of date. Your scalar types, your static types in your source code cannot go out of date. If they go out of date, your code breaks, and then you know to fix it. Static types are documentation that cannot be out of date, which is kind of cool. Now, to be fair, typing will not fix everything. It's not a silver bullet, it's not going to fix all of your bugs. Types will help find bugs, but not all of them. It'll find lots of kinds of bugs, but not every possible bug. Just like testing. Type checkers can also have false positives. In this case, we have this cat in the hat class. It has a welcome method, takes a thing1, calls help cat. Thing2 also has a help cat method. It should work, but the type checker is going to reject this. A type checker will reject otherwise valid programs, and that's okay. So I'm sure someone in the room is saying, oh, so types are useless, we should use testing instead, right? Anyone want to say that? Good. Because testing can be used to show the presence of bugs, but never the absence of bugs. Typing will accept invalid programs. It also is an imperfect testing mechanism. Ultimately, testing establishes an upper bound on correctness. These bugs I know about don't exist. A formal proof establishes a lower bound. This set of bugs cannot exist. And types are a form of automated proof. You need to do both in order to have the maximum confidence in your code. I would say design your code typed first and then test it. No, I don't mean you shouldn't do TDD. I mean, your first line of defense against bugs should be typing. When you have strictly typed code, you need fewer tests, because a large swath of error conditions simply become syntactically impossible. Not all of them, but many. And so that means you need fewer tests to guarantee that your code is error-free. We have, in a sense, outsourced testing, or at least a lot of testing, to the language syntax itself. That's using your brain. That is being a smart developer. That is making our tools do our work for us. Save your brain for the hard stuff, like figuring out what it is your client actually wants. Not figuring out, is this an array, or is this an object, or is this a string? That's the boring, stupid stuff you want your computer to do for you. Thank you. So, I have some further reading if you're interested. Book Understanding Computation by Tom Stewart, excellent book. What to Know Before Debating Type Systems by Chris Smith. It's an article online. I stole liberally from both of these for some of these examples. And I also had an article last year on the Zen Dev Zone on it as well. The slides will be up on Joined In really soon. You can find there, and then I'll tweet the link as well. I think we need to get out of here for the next session, but I'm happy to answer questions if you want to come up and ask. Thank you.